Welcome to the lesson Waves. We're going to look at different types of waves and explore how waves make it possible for us to hear sounds and see light. The vocabulary words for this lesson are medium, mechanical wave, electromagnetic wave, longitudinal wave, and transverse wave. True or false? An astronaut floating in space can hear sounds. Well done. The astronaut cannot hear sounds because there are no particles in space to compress on one another. Waves are disturbances that carry energy. When you talk, you disturb the air and produce a sound wave. When you touch water, you produce a wave. Waves are often classified by the way the disturbance travels. Click each type of wave to explore this idea further. The particles in a longitudinal wave move in parallel to the direction of the wave. Think about a large spring. Pushing the coils of the large spring together and then letting the coils come apart produces a longitudinal or compressional wave. The particles in a transverse wave move perpendicularly to the direction of the wave that the wave is traveling. If you tie a string to a doorknob and move the end of the string up and down, it is an example of a transverse wave. Many waves transmit their energy by disturbing the matter that they move through. Matter that a wave moves through, such as air or water, is called a medium. The particles in a medium move as the wave passes. But particles in a medium don't move in the same way that the wave energy moves. Click the pictures to learn more. Plucking a string on a guitar makes the string vibrate, and this produces a sound wave that travels through the air to get to your ear. Air particles do not travel with a sound wave. As the wave travels outwards, the air particles do not travel outward with it. Instead, the particles near the guitar vibrate back and forth around their original position. The vibrating particles hit particles a little farther away. These particles then start to vibrate back and forth. As the wave travels, air particles farther and farther away from the guitar hit and start to vibrate. In this way, the energy from the guitar string is transferred to your ear. If you have ever gone fishing, you might have noticed that the bobber at the end of your line moves up and down as a wave passes by. The bobber moves with the particles around it. The water particles move up and down as the wave passes through, but they do not move along with the wave. Instead, they transfer the energy to other water particles along the direction the wave is traveling. Energy from the wave is transferred from place to place, but the matter in the medium simply moves up and down a little bit as the energy moves. The medium simply moves up and down a little bit as the energy moves through it. Some waves, like sound waves, need a medium to travel through. Waves that need a medium to travel through are called mechanical waves. Electromagnetic waves, or EM waves, are waves that do not need a medium to travel through. Electromagnetic waves are caused by disturbances in electric and magnetic fields. They can travel through a vacuum. Click on the pictures to see what types of waves are mechanical, that do not need a medium, or that do need a medium, and what types are electromagnetic, that do not need a medium. Water waves are mechanical. They do need a medium. Earthquake waves are mechanical. They also need a medium. Some earthquake waves, like P waves, are also mechanical. You do need a medium for the earthquake waves to travel through. Sound waves are mechanical. Sound waves travel from its source like a saxophone to your ear through the air. Although microwaves in a microwave oven can travel through the air, microwaves don't need a medium to travel. Therefore, microwaves are electromagnetic. Like light, radio waves, and X-rays, microwaves can travel through empty space. Energy from the sun travels to Earth in the form of electromagnetic waves. To listen to the radio, you need both electromagnetic and mechanical waves. How does the music get from the radio station to your ear? To find out, click the radio tower. A signal is transmitted from the radio tower as waves. The radio waves, which are electromagnetic, travel from a radio tower to your radio. The radio waves interact with your radio antenna to produce an electrical signal. To find out what happens next, click the radio. The electrical signals are converted into vibrations in the speakers. These vibrations disturb the air around the speakers, making mechanical waves. These mechanical waves are sound waves that travel through the air to your ears. Now that you've learned about the types of waves, see if you can label their parts. Drag each word to the correct location. Great job! Transverse waves have crests and troughs, while longitudinal waves have compressions and rarefactions. What kind of wave causes particles to vibrate parallel to the direction the wave is moving? That's correct. Longitudinal waves cause particles in the medium to vibrate parallel to the direction that the wave is moving. How is the motion of particles in a medium different than the motion of the wave? You've learned a lot about waves. Let's take a minute to recall what you've learned. Mechanical waves are caused by vibrations. They travel through a medium. Electromagnetic waves do not need a medium. They can travel through empty space. Waves transmit energy, such as light and sound energy. Transverse waves move perpendicular to the direction of travel, while longitudinal or compressional waves move parallel to the direction of travel. Now that you've finished this lesson, click the menu button to exit, or if you wish, you can go back and review any part of the lesson again.